This is a very strange problem because it can be easy and difficult at the same time. When you look at the equation, the left side is equal to the right side, and then if you look and think, if you let n equal to 0. Because whatever the base is, when the number is raised to the power of 0, it is equal to 1. And then, of course, the equation is going to be valid. If n is equal to 0, then 2025 raised to the power of n is also 1, right? And problem solved. All right. The hard part is sometimes we cannot solve a math problem like this. How do we prove mathematically that 0 is the only solution for that equation? We have to do it in a much more difficult and serious way. All right, so now let's turn the left side of the equation to be 2 raised to the power of 2 and then raised to the power of n plus 3 raised to the power of 2 and then raised to the power of n and then plus 5 raised to the power of 2 and then raised to the power of n is equal to 2 times 3 raised to the power of n plus 2 times 5 raised to the power of n and then plus 3 times 5 raised to the power of n. And then the left side can be basically written as 2 raised to the power of n squared plus 3 raised to the power of n squared plus 5 raised to the power of n squared. And then the left side is going to be 2 raised to the power of n times 3 to n plus 2 to n times 5 to n plus 3 to n times 5 to n. All right, now, so basically we have 3 different elements, 2 raised to n, 3 raised to n, and 5 raised to n. How about we let the base be 3 different letters, x, y, and z. All right, so basically the left side can be turned into x squared plus y squared plus z squared. The right side is going to be x times y plus, this is x times z plus y times z. So we're going to multiply both sides with 2. So this side basically become 2x squared plus 2y squared plus 2z squared. It's going to become 2xy plus 2xz plus 2yz. We're going to move the right side all together to the left side, and then you get yourself perfect square formula, right? Basically, you get x minus y squared plus x minus z squared plus y minus z squared, which is equal to 0. If an expression like this is equal to 0, and since these numbers are real numbers, so each element should be 0. X minus y 0, x minus z 0, and y minus z 0. That basically means x is equal to y to z. That means these 3 bases are the same. And that proves that n has to be 0. If you enjoyed today's problem, please follow and leave your comments. I'll see you guys next time.